going to talk about migration. And before I get into any theory or anything too technical, I'll give you a flavor of migration in India and the world. And some of you may have seen these maps, but I imagine many of you wouldn't have. So I'll just give a flavor initially. So are all of you familiar with Night Street Warbler? Yeah, many of you. They're all over Tirupati. I mean, more in previous years than this year, I think. But the small brown bird, incredibly, it breeds here across the taiga, just above the temperate zone in this entire region, and the entire global population migrates down to India, the Indian subcontinent. So all of these maps are not they're not individual birds that are tracked, but just reports from bird watchers. Here, okay. So here we have two other species that again are found in India but only pass through. So there's Amur falcon, which again is really charismatic. Most of you would have heard of it. It breeds in the eastern China and these regions, Mongolia, and then migrates through India in November, December, and goes down to South Africa. Just a little before that, European roller, which is found a little further west along the same latitudes, more or less. A small part of that population passes through India and they go all the way down to Africa. So just an example of huge movements. So these are north-south movements. This is a species that you see in November, December, in peak winter, in the northern hemisphere, they're down in the Antarctic, which is actually summer there. Right? So in the summer in the southern hemisphere, they're down in the Antarctic breeding, and then they move up and winter in the northern hemisphere, which is our summer. So migration is not just north-south, but also Antarctic species come up to the northern hemisphere. Okay, for some reason. But there are effectively four kinds of species in terms of their movements. They're resident species, species that are facultative migrants, which means they don't have to go from the same place to the same place every year, or the entire population does not move. In a sense, they can decide when they want to move. Obligate migration is when they're always migratory, always make either north-south or south-north movements, or so on. Some of them don't go north-south or south-north. And then you can have species that are nomadic, that change their breeding areas based on various environmental factors. So obligate migrants can also be partially migratory in that sometimes some populations remain in the same place, other populations move. So can you name some resident species? Everybody knows, right? Some resident species.
Resident, kabutar.
Yeah. So something like red-whiskered bulbul, jungle babbler, many species that are not great flyers that remain in the same areas. So facultative migration, here's an example. So this is, I think, the yellow rump warbler from the US. So this is in their wintering grounds, in a place where they sometimes winter. The species tends to winter in that area only when prey availability is quite high. So when there's not much prey available in the area, which could be due to a particularly severe winter or snowfall or any reason of that kind, the species stays back or goes to another area to winter. Sometimes they stay back in their breeding grounds themselves. Can you name a facultative migrant around here, something that might move based on resources, based on the availability of resources or the lack of availability of resources at their breeding areas? Crimson back sunbird. Crimson back sunbird, I'm not sure, but possibly.
The flamingos?
Flamingos might be an example. Many frugivores are examples of this. If there's no fruit availability where they are, they tend to roam around, sometimes move large distances in search of fruits. And sometimes these are regular movements, something like orange-breasted green pigeon is an example. They regularly land up in certain places in autumn and other times of the year. But sometimes they don't come, potentially when there's food available wherever they anyway are or in some other place. Obligate migration, one of the best examples is, I gave you a few examples, but here This is, you know what this species is? Yeah, Arctic tern. Migrate huge distances up from the Arctic down to the Antarctic every year. Uh, these obligate migrants also have real site fidelity in winter and potentially in their breeding grounds. But this is one of these American sparrows, not related to our sparrows. But like they do in many studies there, they do some interesting invasive experiments. They took I think it's a white crown sparrow or something. They took it from its wintering area in California, two individuals, left one of them in Louisiana and another one in Maryland, and then waited to see what would happen. And they all went back to breed here. And in the next year, they all ended up in the same spot in California again. So they tend to go to the same area every time. So we have a nice, an interesting example of a one-legged grey wagtail in somewhere near Mysore, where every year, so it's difficult to know whether it's the same bird unless it's tagged. So in some cases you know, some cases you don't know. In this case, there was some form of natural tagging in that there's a grey wagtail with only one leg. Again, migrating huge distances, it would come down to the same spot somewhere near Mysore every year. Yeah. So quite amazing that it managed these huge journeys with a single leg. You have partial migrants, so they do migrate. Some populations migrate large distances. This is a Eurasian blackbird. The populations up here in the colder areas tend to migrate down. Many of the European populations in areas which are not that harsh tend to stay back. So we have lots of partial migrants. Can you think of any? Anybody? Black drongo, yeah, black drongo shows some facial movements. Huh? Yeah, even Bangalore. But it's I think most populations move a little bit. I'm not sure whether that's a good example, but some long distance species, yeah.
Egyptian vulture.
Egyptian vulture, yeah, great example. Many of the Indian populations remain are resident, but there are populations that come down to some of to parts of Rajasthan and all, huge numbers. But other examples would be paradise flycatcher for us. The South Indian populations are more resident, are more sedentary. North Indian and Himalayan populations tend to come down. So in the south, you have every population at the end. Graded candy flycatcher, which has lots of isolated sedentary populations, and you have the Himalayan populations coming down. Pied cuckoo is another great example of this. So there's so you see that this resident population here in summer, pied cuckoo in South India, and then you have the African birds coming in monsoon. So they come fill up most of the country, and then they leave post monsoon. By November, December, they're more or less gone, and you have only the South Indian population remaining. Then nomadism. So nomadic birds are those that tend to shift their breeding ranges based on food availability, or even their wintering areas based on food availability again. They're mostly in very harsh conditions. So this is some African species, I forgot which one. This is their breeding areas in 3 years, and you see they've completely shifted. It's quite a large area, and they've changed their breeding locations based on the availability of some food. So this is also similar to what some species in the high Arctic do. Like this is a parrot crossbill. So parrot crossbill, sometimes there are influxes in southern Europe. Not southern Europe, but central Europe. That when there's an abundance of food there or a lack of food up in their breeding areas. So these are species that are not really migratory. Then they tend to move for certain reasons. Mostly they're sedentary. But there are huge influxes of parrot crossbills that come into Central Europe and then go back. Waxwing is another species where these are both dietary specialists in a sense. And again, waxwing, there are big influxes when there is a lot of food available in a certain place. Some other interesting tidbits about patterns of migration. This is Eurasian cuckoo, common cuckoo. You see them passing through in this area. Did you see any common cuckoos this year? People from Tirupati? No? None this year. So usually, they have these, some years there are lots that go through, some years not so many. But these are some individuals that were tracked from Northern Europe. You see that they followed a bit of a cyclic route. Many species tend to do that. So these what look like clocks just show their orientation, the orientation of their movement during different parts of their journey. So you see that it goes all over the place. Yeah, and they go sideways quite a large area before going up. Oriental pratt and coal, again an interesting tidbit. So Oriental pratt and coal, did you all think of it as a? Did you hear an interesting story recently about Oriental pratt and coal? You might have. Some of you have. So Oriental pratt and coal was a species that all of us thought was maybe moved around locally, stayed in India most of the time. But then recently we found out that there's a huge wintering population of many million birds in New Zealand, and one of those birds was tagged with a geolocator, I think, or a radio tag. And then we found out that that bird went all the way from all the way from Australia up into I think somewhere near Cambodia here, and cut across the ocean, landed up in Orissa, and then finally settled down to breed in Karnataka, which is incredible. It was unthought of in a sense, at least for that species. So there are these huge movements for some of these species. So it bred in Karnataka. Some people went and found the tag and found the bird, etc. And then it started its movement again. It I think went somewhere near Chennai, and then little south, and then it tried to cut across the Indian Ocean and go to Andamans, but it was stopped by a cyclone, and then it ended up in Sri Lanka, I think. So I don't know what the current status is for that bird, or where it's going to end up in the winter, but it's doing the rounds. There's a huge distance here. Okay. So migration can also have some genetic underpinning. So for example, for many species, you see that populations, based on where they're situated, move winter in different areas. So for example, here you have the most northern populations of willow warbler. It's a Phylloscopus warbler in Europe. Winters in sort of northeast Africa and Central East Africa. And the most southern populations, some of the most southern populations, winter near Morocco and those areas. Similarly, this is with species in US, Canada. You have a couple of races here. One is a coastal race, and then there are places where both races are found, are hybrids. And then you have in that both races have contributed some genes. And then you have inland ancestry going further in, and you see that these populations seem to migrate to different areas. One of them goes to Mexico and those parts, and the other one little further down into South America. So these are migratory flyways for raptors. So some groups of birds have very strict routes that they follow. For raptors, it's especially important because they cannot go across the sea much. So they follow inland routes. So in many places, they narrow down into the same channels. Many species of raptors narrow overland channels. And in parts of Israel and I think even in parts of Southeast Asia, you have incredible aggregations of raptors of many species. So I think you see hundreds of thousands or maybe millions of raptors flying over Israel, which is a really narrow overland route, which is not the desert. So they all funnel through this tiny area and then on their way down to Africa. Unfortunately, in India, we don't have any bottleneck for raptors to go through, any overland bottleneck. They just fly across the whole area. These are for raptors. Then you have these migratory flyways that have been identified for shorebirds. So there are only 8 migratory flyways globally for shorebirds. And here you see that the ones that come to India, mainly the I think the Central Asian flyway, this one. Then there is the West Asia, East Africa flyway, just about touches India. Of course, there can be a little bit of deviation from all of these, and the East Asian, Australasian flyway again comes to part of Northeast, and birds from there come down to Andamans and such places. So you have these pretty broad migratory routes that birds follow. So how do birds migrate? So before that, I mean, there are two ways in which they can do it. They can navigate, in that they can, if they get a sense of the absolute geographic position at every point of time when they're moving down, when they're moving anywhere, then it will be easy for them to navigate. If they have a sense of the absolute geographic position and they know where they want to be. Orientation, again, when I say know and all of that, these decisions are not necessarily conscious. So otherwise they can orient themselves through some object, like the sun or some celestial bodies or even other cues, to orient themselves in a particular direction. So a big question is, can birds perceive magnetic fields? Because that would be an immediate way for them to navigate or orient themselves. So apparently they can sense magnetic fields through some magnetite present on the upper layers of their bill, and it's unclear whether this really contributes to anything during migration, but they do respond to climatic events, to these geomagnetic disturbances that are sometimes very far from where they are, and they change their migratory routes based on that. So there is some sense that they can detect magnetic fields, either through that mechanism or through their eyes, where there is little more evidence. So their eyes in some way are involved in sensing magnetic fields. Although the cues may not be visual, the cues are not that simple. Yeah, but the receptors are present in the eye. There are some studies which have looked further into that. You can take a look, check out studies that have looked at magnetic cues in the eyes. Then birds are known to orient themselves to the sun. So this is a study again that was an interesting study where they took some passenger pigeons and locked them up in a room for a while, and they changed their body clock in a sense. So what they did was they had artificial light so that they would think that it's a 6 hour. It was 6 hours after the usual periodicity. The sun, that is, to give them an idea of that. So what happened was they released them from the same place, and the ones that were not, these are the control ones, in that they weren't subject to this treatment. They always flew down to the correct area. The ones that were released, the ones that were kept in isolation, right, and were either put 6 hours behind or 6 hours ahead, ended up going in directions that mimicked the periodicity that they got used to. So they were orienting themselves to the sun, but at a schedule that wasn't really what it really was. So then some birds use celestial guides. There is even some thought of whether they use olfactory cues. There is some evidence, I think, but not much. Still unclear, at least locally in a place. So going on from here, there are some physiological adaptations that birds need before they migrate large distances. One of the most clear ones is fattening. So they get layers of fat deposited before they migrate to see them through the large journeys. And migration is possibly responsible for a very large proportion of mortality that birds face, especially migrants. So this is a study with ospreys and some other migrants. So you see that spring migration is when most birds die, not so much otherwise. A little higher in fall migration as well. Fall is autumn, spring is before summer, and most of the mortality is during migration. They are more vulnerable to predators, they will be more tired, there's a big loss in body condition when they're migrating. So birds not just migrate, some are obvious migrants, but they tend to disperse. There is dispersal, every species tends to disperse from their breeding areas to get at new territories, etc. Some of them tend to move more than others. So this is a species that till the 1800s, I think 1870, was found mostly in India, East Asia, Southeast Asia, and Africa. But in the last 150 years, has moved all the way throughout North and South America, and further down from here into Southeast Asia and into Australia. Does anyone know what the species is? It's good that it's not clear from the photo. Egret is right. No, pretty good, yeah. But which egret? Yeah, cattle egrets. Yeah, so they've moved all across the world now. And it's not that they were introduced in many places. They've either used some assistance from humans, maybe through ships, etc. But it looks like in some places they've just moved on through their own initiative. They've just dispersed down into all over the world. Some other examples. Some species have expanded their breeding range. They're a resident bird, I think western bluebird in US. And this was its historical breeding range in this area, but it's expanded all through that entire region now. So can you think of an example in India? A species that is expanding all over the country, expanded,
Crows.
which one?
Crows.
Alexandrine is possible, but Alexandrine is also, there are also escapees. So you have cage birds that escape and establish in places. So it's not clear whether they're expanding range right there, I mean from their range itself. Which one? Pigeon. Pigeon is true, yes. They have. Kite maybe not, they were present all through. Okay, so peafowl. Have any of you noticed peafowls expanding?
Yes.
Yeah. So they've expanded all through Kerala. Initially, they were only found in one or two small pockets in the state, but for whatever reason, perhaps through drying of habitats or like little more degradation or opening up of certain gaps that were not possible otherwise evergreen forest barriers, they moved all over the place. They moved all over Kerala. They moved all over Bangalore, where I'm from. They're there where they were never there. They moved all across the Western Ghats into rainforests which have 8,000 millimeters of rain a year, which is completely unsuitable for peafowl otherwise. But all of these places have degraded a little bit, so maybe that's allowed peafowl to move through everywhere. Common myna is a great example of an invasive, great invasive species, in that they either move with humans or they move through cages, because common myna, like most mynas, are very popular cage birds. And they've been introduced and established in various parts of the world, especially on islands and in such areas. This is a northern meteor. So northern meteors were not found anywhere in the Americas till recently, but populations from Western Europe have expanded into Eastern North America, and populations from Eastern Asia have expanded into Alaska, which is close to East Asia. But interestingly, these populations follow their ancestral migratory routes, where they still come across most of the world to come into Africa, all the way from Alaska and these areas. So there is, although these birds expand, they still retain some their ancestral migration memory. So I mean, we've spoken about all this, but how do people know so many things about migrants and where they go and where they come from? Mostly through radio tags and geolocators, these small things that are put at the back of birds, and more recently through citizen science, where if you have everybody in the world watching birds all the time, then you get an idea of where a bird is and where it isn't. So I'll end with a small case study from the Arctic. I mean, it's a nice story. So I mean, we have all this migration, but how are migrants reacting both to climate change, to all the perturbations that we have around us? And one of the most sensitive regions in the world would be the Arctic, because snow is melting at rates that were unprecedented, and snow cover is reduced greatly. So this is what the Arctic looks like. It's a bit of looking at the globe from the top, right? Does that make sense? This is Scandinavia, this is North America, this is East Asia, yeah? And this is the high Arctic, where a large number of shorebirds breed. Many of the ones that we see here, curlew sandpiper, dunlin, sanderling, they all breed in the high Arctic. So it's a huge area, but very specialized habitat in summer. So they're Arctic fogs. Yeah. So as we all know, temperatures have been rising all over the world. but temperatures have been rising in the Arctic. So you see 60 to 90 degrees north latitudes, even higher. I mean, they've been increasing even more than elsewhere in the world. So this is in comparison to what it was or what it should be. Redder is a greater difference from expected temperatures. So you see that these temperatures are the areas which are much warmer change based on season, but you see that there are large parts of the Arctic which are much warmer than they should be. So because of that, snow tends to melt earlier, right? If snow melts earlier, insects tend to come out faster. So if insects come out faster, there are consequences for birds. So these long distance migrants, this is I think red knot, right? A long distance migrant. So ideally what it would like is its migration is timed such that it would, when it reaches the Arctic to breed, right? It's just before the peak availability of insects, and then when the chicks come out, it coincides with the peak availability of insects, right? So the chicks get great food, and they go out and with great body condition, a nice fat red knot. So now with warming, this peak is early, right? So snow melts about, maybe a couple of weeks earlier, which is actually a really large amount in the Arctic. And what happens is peak insect availability is before the chicks hatch. So the chicks get substandard food, and then you have very poor body condition red knots coming out. So this can have big consequences on their survival. So in this map, should take a look at this one specifically, this last box. So this shows the on the y-axis we have date or some index of time, right? And this is years. So as you see, as we have in the last 12-13 years, the time of the year when snow cover comes to 20% has declined quite rapidly. So you have 20% snow cover a few days earlier than now, then a few days earlier than it was in 2003, right? So ideally, what we would like shorebirds to do, and I'm sure what they would like to do, is to coincide their migration, their arrival in the area, right, with this difference in snow melt time. So they want to reach a few days earlier. So if you look at this, almost no shorebird is able to keep pace with that. So they're all able to adapt. They're all arriving a little earlier than they used to. Of course, they would need to, but they're just not able to keep pace with the rate of advance of snow melt. Except for maybe the species, the western sandpiper, that seems to be doing perfectly well. But most others are, these are just flat, and these are really going to be hit otherwise. If they don't adapt soon. This is, there are researchers who have looked at this across the Arctic. So evidence for this, for birds not being able to keep up with advanced snow melt. So this is the red dots are when the mismatch is occurring, but birds are not keeping pace with environmental change, right? So in many parts of the Arctic, there is evidence for this, that birds are not able to keep pace. In some places, birds are keeping pace. In other places, their mismatch is occurring, but there are no negative consequences on growth. So here, they have also found negative consequences on growth, right? So anyway, so why do birds not advance egg-laying dates? Why do they not go earlier? Why can't they keep pace with that? Because clearly they are able to sense this change in food availability, but why are they not able to do it? One reason is that some of these migratory jumps that birds have to make are rather long, right? But although they are really, that some of these are long, there is a very short period. So actually, I'll just take you through this graph first. So for many species of shorebirds, so you have a time when they begin fueling. So this is in their wintering area, right? Jan, Feb, they're already in India. Most shorebirds are in their wintering areas, and then they start fueling somewhere in end of Feb, early March, right? So they need to fuel for migration. So they develop, they improve their body condition, they eat a lot, so that they can make these long flights back. So then it takes them some time to build up that body condition, and then this is when they leave their wintering grounds. And if you see, there's a really tiny period between when they depart from their migratory grounds, which is possibly 10,000 kilometers away or more, to their arrival in their breeding area. So there's a very short period, short window when that they have there. So this window potentially cannot be condensed any further because these are windows where they also need stopovers. They cannot do their entire flight at once. So there's a very tiny amount which they can negotiate with because this entire period is taken up in developing body condition. If this is brought a little earlier or this is brought a little maybe. So if there are changes here, the birds may not be able to make it through. There might be more mortality. So yeah, there's a very tiny period even here between arrival and laying eggs. So now if you want to get this further back, then arrival might have to be further back because they'd have to come and court and breed, etc. This period would be tiny. So this graph over here, do you have another minute or two? Yeah. So this graph over here, I mean, just an indicator. So there are some. There's been a lot of work on spoonbill sandpipers, especially, and some other species that breed in the Arctic and come down to Southeast Asia. There have also been work on species that in northern Europe, coming down to Africa. So I think this is Bartail Godwit, maybe Bartail Godwit, right? This yellow dot here is a staging site. So this is a site which they use to stop over and feed a bit before moving up to their breeding areas, right? So if you look at this, they are arriving. So this is when they used to arrive in 1995 and when they arrive now. So their wintering areas themselves, I mean the breeding areas themselves, they seem to be arriving a lot earlier. They seem to adapt it a bit and they are arriving earlier. But they are arriving at their staging grounds at the same time, almost exactly the same time. So actually the distance between here and here remains the same, but effectively they are spending less time in their in this staging site, right? Much less time. So what this would mean then is that the amount of food available here at the staging site has to be really, food has to be extremely abundant there. Right? If you want this, want them to adapt to that, then there are various staging grounds around the world. Some in the Yellow Sea, some famous ones in the Yellow Sea in East Asia, and many others. These have to be of extremely good quality. Yeah, that's it.